In this video, I will show you one design mistake which I see very frequently in practice. Namely, many programmers firmly believe that every web API they design requires a service layer. That is not true. Anyway, the confusion exists. I don't know why and where that came from, and so in this video I will show you one small web API in which I plan to show you how you make that decision whether there is the need for a service layer or not. And the decision will be very easy to make in the end. This is an endpoint implementation in a simple web API. It is typical in many respects. The endpoint receives a request DTO, validates the DTO against the database to produce a civilized error report. This is not necessary, but it's nice to have. Eventually it does the work, saves changes to the underlying database, and, very importantly, prepares the response DTO. Any other command in this web API would have the same structure. Validate against the database, do the work, update the database, construct a response. Queries are different in the sense that they are simpler, and that's it. What can we say about this API? What I see at first glance is that it writes into a single database. It might read from many data sources, but it writes into one. It never writes into two independent data sources. The key term which I will introduce at this point is that none of these endpoint implementations requires an orchestration of different mutable entities. Nevertheless, let's assume that we have decided to implement the service layer, and I will do that right now. There will be the services namespace. There would be an abstract service that manages company data. It would create a new company, update the fields of the company, then manage addresses of a company, support searching the companies. Those are the operations the company service must implement. But the choice of these operations is not accidental. Each of these abstract methods implements one transactional boundary, and by doing that, it implements one use case. And so I will specify the responsibilities of this service. It is defining and managing transactional boundary. It is also responsible to enforce authorization rules, but not authentication. On the technical level, it would support asynchronous execution. It would support cancellation too. You see, my beautiful set of abstract methods becomes to grow larger now. But there is more. The service must also return meaningful errors. More responsibilities remain. I should have defined error model and separate input-output DTOs. The service layer should speak its own language, not to reuse the language of the layers above it. That is a design flaw. Now, is this a good design? The bloat is sneaking in, but still I do have those principal elements like managing transactional boundaries. That is very important. I also have the separation of use cases, one per method. That is very good, but is this a good idea? The best way to see how good an interface is to use it. I will re-implement one endpoint, the one which updates a single company address, and that will finally tell us when it is a good idea to introduce the service layer and when it is just a waste of time. Before I show you this final revelation, let me remind you that everything on this channel is free thanks to the patrons. If you like what you have learned from this video and from all other videos on my channel, then please join the community on my Patreon page and help me maintain this channel free forever. Thank you very much. Now, the endpoint would receive the application service as a dependency. The remaining arguments are the parameters to the use case. You cannot avoid them. And then it begins. we would delegate the use case to the service layer, analyze errors and return bad requests if any happened. This is very simplified approach to errors. I don't even think it is correct entirely. If no errors occurred, we would return the OK result. Now, is this how you would use a service? What do you think? No, not really. First, the service would not use the same DTOs which the web API is using. Those are two different layers. I would have to map every DTO before returning the response. The errors are not just a list of strings. Oh, there would be a translation from the errors model to an actual HTTP response, including possibly localization. It's far from trivial. And of course, there would also be a translation of input DTOs into whatever DTOs the service layer is using. Therefore, it's not possible to just use the service. There is a lot of boilerplate code around it. Every service comes with boilerplate. You need to sustain that. You need to implement that code to be able to use the service. So again, why? Is there a reason to do that? For a web API to have a reason, it would need to depend on another mutable service, and another one possibly. It would need to orchestrate changes in multiple places. For example, changing your local database, but also managing the payment gateway or something like that. You would definitely need to orchestrate things that happen in two systems. I don't have that in my web API. And quite often, you won't have two mutable, transactionally independent systems to orchestrate in your web API. You might be reading from multiple data sources, but that's a completely different thing. You're not changing them, you're changing only one. Also, when there is one-on-one relationship between the web API and the service layer, then even the DTOs are an exaggeration. Errors are much simpler in that case too. So I don't need any of these added bloat. In the end, this would be my endpoint implementation. Just check whether there is an error and return bad request, or otherwise return OK and the object that is the result of the operation. Most of the web APIs and components and services you will ever write look exactly like this. Only sometimes the reasons for a separate service layer will be satisfied, just as I've shown you in this video. I told you, the decision will be easy to make in the end.